Okay, so here if we wrote, we have 3 objects and we need to pick 2 objects out of 3. So permutation of 2 objects out of 3. So we are picking 2 objects out of 3 objects. How we write it? 3 factorial, the first one, divided first minus second. So 3 minus 2 factorial, and this would be the we can get the answer. Okay, there is a way on the calculator, you can find on your calculator that you have the same, but it's written as NPK, in some cases NPR or NPK, it is the same thing. So here this is the number of objects which you will pick, and this is the total number of objects. So we'll write on the calculator this number N, you write N first, and then on the calculator always it would be shift something. One of the buttons on the calculator, it differs from one version to another version. So shift and get the P, the permutation symbol or notation, and then write K equals, it will give you the answer directly. But if your calculator is not allowed in your university or institute, so it is very easy, you can expand it and you can answer it. Okay, it doesn't require, if calculator is not allowed, so it doesn't require. I think it would be a simple one and all of them would be canceling each other except maybe 1 or 2 number which you can use the timetables. Okay, okay, so here in NPK equals N factorial divided N minus K factorial. Okay, easy, just I'm trying to make it easy for you to memorize it. I hope that so far we understood, but to memorize it, so we'll take the first one, we'll put in the top, and then this minus this on the bottom here. This is the permutation. What about the combination? Combination, the easiest way to remember it, it is, for example, the symbol for combination, we said it is C. So we can say here, we have to choose, as I said earlier, here we have to pick K out of N. We have to pick K out of N. This is in case of permutation. In combination, we said we have to choose K objects out of N objects. Okay, so we choose K objects out of N objects. So how we can write it? It is easy. Just convert it into permutation. So it will be NPK permutation. We convert into permutation. So the same thing here, we wrote it here. Okay, NPK divided what? The second one, the last one, this one, K factorial. That's it. So again, NCK or NCR, depend on the version or the notations which you are using in your notes. So NCK equals, we'll use the same thing here, the same thing, but just we'll change the C to P. So it will be NPK, that's it. So we converted into NPK, from NCK to NPK, permutation problem. But we have to divide the permutation, divided KI, K factorial, K factorial. Okay, okay. Coming to this example, if we looked here, you remember here the permutations was 6, the number of ways, and here we found that is only 3 because we cancelled 3. So if we consider here NCK equals NPK divided KI, so we'll get the result which we'll get, we have already got from NPK here, 3, 2, the same problem, the answer was 6. So here NPK, okay, 6 divided 2I, which is K, 2I. So the answer is 3. It is very easy. So how we can, yeah, I don't need every time to rewrite again npk and ki. So I want to write it in terms of n and k only without going back to the permutation. Okay, so it is also easy. nck equals, what was the permutation formula? It was the first one, ni n factorial divided n minus k factorial. Okay, this was the permutation. Okay, you remember, just we mentioned here, it is the same thing. This is the permutation now. We just type it here, but we have here in the denominator ki, so we have to add here ki. Okay, so we'll add k factorial. Okay, so we have n factorial divided n minus k factorial times k factorial. This is the only difference, that you are adding here in the case of C combination, you're adding the k factorial. You're adding the k factorial. And the permutation, just we have an n minus k. But here we have n minus k and we have k, the number of objects which will be selected, added here. So this is as simple as that. This is the combination formula. We'll come to it into details with examples as well. Okay, I hope it's clear. So this is the formula here for combination. Okay, equals, I converted the C to P, NPK divided KI. Okay, NPK equals N the N minus K, and here times KI. So here 3 permutation B, we get it from the previous example, which was 6. Okay, 2 factorial, we can cancel 2 times 1, 2 times 1, 2 times 1. That 1 doesn't matter, we no need to type 1. So the 2 will be cancelling with 6 and will end up with 3. Okay, okay. So this was for the notation and the formula of the combination. I hope it is clear. So let us clear the sheet. Okay, so now we already understood the permutation order matters, and we got the formula or the notation and the formula of the permutation, and we get in touch with the combination. We'll come to it later in the next slide. But here, to complete one thing on the permutation, we have only talked 2 cases. In case if we have n, for example, equals 7, and we are using all of them, we are not picking k. So the k here is all of them. We are not picking from them. We are using all the 7 objects which we have. In this case, it will be ni. If we are using all the objects which we have in the set or in the population, if we are using all of them, so it will be ni. This is the number of ways. Ni, number of ways, equals ni. Okay, equals ni. And I have proven to you that we can use the formula n divided n minus ki, which will show to us that 7 divided 7 minus 7 factorial, 7 minus 7 factorial, which is 0. So it will be 7 factor as well. Okay, it will be 7 factor. Here, what if we have a repetition? Just before moving to this, maybe we'll come in touch with one of the slides which was given by the Debrecen University to get the Debrecen student attached with their slides which they have. Okay, I think this is the one. Okay. If you recall here that we have mentioned that on the exercise we have how many permutation of a size 2, which is k. This is k. can we make using an element set of 1, 2, 3, and 4? This is the set which we have, so we can have all these numbers. This actually was before before learning the formula which we have for the permutation. So the answer is 12. If we try to make this one, so we can write it n equals total number equals 4, the size k equals 2. So the number of ways is n. Order matter or doesn't matter? Here it is permutation. He mentioned so order matter. npk equals n equal 4. So 4, 2. So it equals 4. 4 factorial divided 4 minus 2. Okay, factorial. So equal 4 factorial divided 2 factorial equals 4 times 3 times 2 factorial divided 2 factorial. 2 factorial will cancel, so answer is 12. As simple as that. Okay. Here, if you remember, I told you that in some of the permutation, they're using instead of NPK, they're using permutation NK like this. And in this case, they are using, instead of dividing, saying Ni in factorial dividing N minus K factorial. No, they are substituting this with this formula. We said that we'll start with N times N minus 1 times N minus 2 and so on up to what? Up to N minus K plus 1 without denominator. Okay, so N minus K plus 1. This is the answer. Okay, without using denominator. So normally when we say NPK equals Ni in factorial divided N minus K factorial. Okay, this has numerator and denominator. Okay, but in some cases they said NPK, the same thing, equals N times N minus 1 times N minus 2 times N minus 3 and so on until we reach N minus K plus 1. Okay, so okay, let us try this on the previous example so we'll have better understanding. If you remember this example which we just answered now, and the answer was 12. Okay, let us erase it and answer it here. So with the same methodology, so N equals 4, K equals 2. So the number of ways equals, we'll start with N, 4. So N minus K equals 2 plus 1 equals 3. So we'll start with 4 and we'll end up with N minus K plus 1, which is 3. So it will be 4 times, and we'll go downward until we reach 3. This is the next number. In this case, so it will be 4 times equals 12. There, 12. Okay, this is another way. Okay. So here in Debrecen University, they are explaining the two ways. It can be written permutation in NK, and we go N minus 1, N minus 2, and so on up to N minus K plus 1. Okay. And you can write it also in this way. So it will be N factorial divided N minus K factorial. This is actually the way how it is, or this is the proof, actually, the proof how we arrived to this formula. If you look at this formula, of course, we cannot have any denominator which is 0. So the N, K, and then in this case, normal scenarios cannot be 0. But In the factorial cases, it can be 0. So factorial cases, 0 factorial means 1. So 0 factorial means 1. So n can equals k. That's why you find here n and the k could be unequal. But the point here that the k cannot be more than n, because in this case it will be fraction. For example, if we put the n 3, let us put n equals 3 and the k more than n, so k is 4, c is 3, 4. So what will happen? You'll have 3 divided minus 1, which is minus 3. We said that the factorial of any minus any negative equal infinity. It cannot happen. Factorial of any fraction also infinity. We cannot use it. So we have to avoid this. Okay. That's why you'll find here the k is greater than or equal to 1. Okay. And less than or equal to n. Okay. Coming here to the permutation, this is actually the proof of how we arrive to this expansion, or the number of ways to execute or to arrange the number in the permutation, which is n minus 1, n minus 2, so on, and up to n minus k plus 1, which is just we have mentioned in the previous page. The proof is not required, but just for your knowledge, it is the same function. So these two functions are the same. This one and this function are the same. Okay, so here we are coming to a new permutation. As we said in the previous example, if we are using the whole n, so k and n are the same. If n equals 7 and the k equals 7, so I'm selecting all the items in the set, which I have all the available items in the population. So n and the k in this case will be the same. Both of them will be n. I have already given this example earlier, so it will be n. So it will be npk will be equals npn. So n here, n minus n here, it will be 0. 0 factorial equals 1, so ni. Okay, so this is the case where we are selecting all the items. Okay, for example, you have 5 and you are selecting the whole 5. Okay, but it's not every time that we are selecting all the items, it has to give us ni. There are some special cases. Permutation, so far we have mentioned two things. We have mentioned that we are selecting all the items, n equals 7, for example, and the k equals 7. So in this case, it will be ni. Okay, if I have n number of objects, I'm using all of them, so the answer straightforward will be ni. But if I'm picking from them k, so I have n equals 7 and the k, for example, equals 3. So I have n and the k. If I have n and the k, the formula will not be ni or n factorial. It will not be n factorial. The formula in this case, it will be picking k items or k objects out of n objects. It will be equal n factorial divided n minus k factorial. This is the general formula which we have for the permutation, which is same as this one, but subject to we are choosing here all the items. Okay, so now we have learned two formulas. One if we are selecting all the items, and one if we are selecting only part of it, k. So what if I'm selecting all the items, but there is a duplication or repetition? How there is a duplication or repetition? This is what we are going to understand in this example. So here we will be talking about the permutation rotation when we are picking n object, okay, but there is a repetition r. R is the repetition. For example, find the ways the number of ways the word algebra can be arranged. So here he said algebra. So we are going to use all the digits, all the objects, all the alphabetical letter in the word algebra. So 1, 2, 3, 4, 5, 6, 7. We have 7 letters in the word algebra. We are going to use all of them. So definitely the answer will be in I. We have 7 number and we are going to use all the number. And he's asking how many ways we can arrange all the number. He did not say select 2 or 3 letters of algebra and use them. He said how many ways we can rearrange the same word. So he intended to use the seven digits which we have here, or the 7 alphabetical letters. So the answer for sure it will be NI. But here we have a special case. You remember we said in the permutation, what happens? The order matters. So for example, if I have a word starting with A and the other word starting with A and the same arrangement are there, does it matter? No. It is, starts with A alphabetical letter. So here, if we notice, algebra has one alphabetical, one A, and here another A. So we have two A alphabetical letters. So if this letter came at the beginning of any arrangement, or this A came at the beginning, it doesn't matter. All of them or both of them will have the same order because there's no difference between this A and this A. Okay, so here we have repetition, they're calling, or duplication. Okay, sometimes they're called duplication or they're calling repetition. So how we can do that? That remains in I because we are using all the letters. No, we have here n equals 7. So we have to count how many numbers repeated, how many numbers are repeated. So in this case, I will write n equals 7. I will not use k because I'm not picking from this algebra. I'm not picking anything, 3 or 4 digits. I'm using all of them. But I have a new thing called repetition. Repetition means I'll use the notation R for the repetition. How many repetitions I have? 2 repetition. A has been repeated twice. So R equals 2. Is it one letter or 2 letters? Here it matters. If I have one letter repeated, so I have to write how many times it is repeated. If I have 2 letters repeated, so I have to write R1 and R2, R3, R4, and so on. This is what we'll come to know in the next example. So here, just to make it simple, repetition 2 R equals 2. So if the formula remains, because we are using all digits, right? So formula should be in I, in factorial, right? Yes, it is remain the same number of ways remain in factorial, but we have to divide by R factorial. We have to divide by R factorial, the number of repetitions. So in this case, okay, we have the letter A repeated 2 times, and it doesn't matter which A or this A came first. It doesn't matter here. It's not. It doesn't mean combination. Here, it is orders matters. Order matters, but whether this A or that A, it doesn't matter for me which A comes first. Both are A letters. Okay, which of them came first? So the number of ways will be here 7, 7 factorial in factorial divided 2 factorial. Okay, if you calculate on the calculator, it will be 2,720. Okay, okay. So let us take one more complex example, which it may help us to understand better. So in this example, how find the number of ways the word Mississippi can be arranged. Okay. How many digits or alphabetical letters in this Mississippi? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I have 11 numbers, 11 digits, 11 alphabetical letters, 11 objects available. So n equals 11. But if I can notice here, I notice that I is repeated. Okay, I is repeated how many times? 1, 2, 3, 4. I have 4 I's, 4 I letter. Okay, I letter repeated 4 times. The S letter, the same thing, repeated 3 times. And P repeated 2 times. Okay, does it matter if this S or that S came first? No. This P or this B? No. This I or this? No. So how we write it? We are using this all the letters of Mississippi. So this is n equals 11. Here we are not picking, so there is no K because we are not picking anything. We are using all of them. So the only thing here we have the repetition, which is R. R equals 4, or R equals 3, or R equals 2. I have 3 repetitions. So here we have R1 equals 4. R2, R1 equals 4, which is I letter. For S letter, R2 equals 3. For R3 repetition, the third item which is repeated, P repeated 2. So the answer will not be n factorial, number of ways, because we are using all of them. It should be n factorial. No, it will be n factorial divided R1 factorial, R2 factorial, R3 factorial. Okay, so here it will be 11 factorial divided 4 factorial, 3 factorial, 2 factorial. Okay, and I cannot multiply these together. Okay, I have to choose the biggest one of them. So I may write it up here just to remind you how to expand it. So it will be 11 times 10 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. Okay, and here down 4 factorial. So I use the biggest one of them. So this 4 factorial will be cancelled with 4 times 3 factorial times 2 factorial. Okay, I cannot also multiply this. I have to expand them. So it will be 11 times 10 times 9 times 8 times 7 times 6 times 5 divided 3 times 2, which is 3 factorial, 2 times 1, which is 2 factorial. Okay, to avoid confusion of decimals. Okay, so this would be the answer. We can get on the calculator. Even directly you can get on the calculator, but you have to write the right formula here. Okay, so this example has been given here also. They've given, I'm using all of them, so they wrote the permutation because there is no K. If you remember, they were writing it in P permutation NK or PNK. But there is no K because we are not picking. We're using all the number of alphabetical letter, all the objects which we have. So in this case, there is no K. There is no K. So they're writing it PN. PN means permutation of using the whole number of n. Okay. But here with they said identical, repeated, duplicated, whatever. So this is the example which we just have given. It will be ni, okay, which is normal. And if we are using all the numbers, all the n numbers, it will be answer will be n factorial, but we have to divide by the number of repetition, which will be r1, r2, r1 factorial, r2 factorial, r3 factorial, or could be k1 if they're calling it k1 factorial, Here also you can use K as a repetition because there is no K in this option. But if you have K and you have R, you have to distinguish between them. So maybe needing to use K and R. So K1 factorial, K2 factorial, K3 factorial, and so on. Okay. So for example, here the example that I've given about the University of Debrecen. Debrecen, there is no repetition except for the E alphabetical letter. You have E repeated 3 times. So E, K, or R equals 3. N equals 1, 2, 3, 4, 5, 6, 7, 8. 8. Okay. So it will be Ni, but divided Ri, or Ni divided Ki. Okay, which will be 8 factorial divided 3 factorial. So the number of ways it will be 6,720. Okay, this is simpler than the word Mississippi, which we have taken the previous example because we have a lot of repetition there. Okay. Let us clean this slide so we can continue. Okay. So I hope that this example of the word Mississippi is clear because here this is the most difficult example which you can face where you have 3 repetition for the word I, for the word S, and for the word P, and all of them will be written as factorial in the denominator. Okay. Okay. Example number 3 here is if you have a committee of 12 staff. Okay. So N is 12 in your company. N equals 12. How many ways there are for choosing a chairman, chairman assistant, and secretary? This is what we have mentioned earlier at the beginning of explaining the permutation. So it is a clear case of permutation because chairman is not same as chairman assistant is not same as secretary. Any of the 3 arrangement is different. Okay, everyone will be looking for a chairman position. There's an advantage of being a chairman. Okay, so here the order matters in this problem because the person who will be selected as a chairman position will be different than the one who will be selected for the other. So K n equals 12. So how many people I need? How many I need to select out of 12 people? Out of the 12, how many people I need a chairman, chairman assistant, and secretary. So I have to select 3. So K equals 3. So this is the way I have to identify N and K. If you identify these 2 rightly in all the combination and permutation problem, it will be very easy and very simple to answer the problem. So N here equals 12, and here we count. He did not give 3 or 2, but he mentioned the title, the position of these people: chairman, chairman assistant, and secretary. 3. So this problem it will be written as NPK equals N 12, 12 picking 3 out of them, which will be 12 factorial divided, okay, divided what? This minus this, 12 minus 3, all together factorial, okay. And then, so it will be 12, here 12 minus 3 equals 9. So I have to expand the top one until I reach 9, so it can cancel each other. So 12 times 10 times 12 times 11 times 10 times 9, 9 will cancel with the 9, so this will be the answer. Also, you can use the same way which was given by some of the books. We can, in this case, 12, we'll start with 12 and we'll end up with 12 minus 3 plus 1. So here, 12 minus 3 equals 9 plus 1 equals 10. So I can write 12 times 11 times 10. That's it. This is the answer directly. If you notice, it is the same thing here: 12 times 10, 11 times 10. You remember we said that start with n minus 1 up to n minus k plus 1. Remember, this is the way we said without having numerator and denominator. So this is the number of ways we can have, which is 1320. I hope now the permutation become very easy and we became familiar with it. Then we can start with the combination, which is anyhow it is the same concept of we're not going to repeat, just we'll continue on what we have learned on the permutation, because it is very easy to convert combination into permutation just by dividing by k factorial. That's it. So here, if you look at the combination, it is permutation of the same thing, nk divided the number of arrangement which will have, or the number of objects which will be selected. So nck equals npk divided ki. In other words, we can expand this one, npk equal n factorial divided n minus k factorial. So it will be the same thing, nck equals n factorial n minus k factorial, and because this combination will be divided by ki. If you can notice here, we have this term in the denominator. So always the number of ways for permutation, it is larger than the number of ways for combination, because permutation, the order matters. So if you have TA, it is not equivalent to AT in permutation. So both of them will remain in your choice. But TA and the AT in combination, one of them will be cancelled because both of them will be the same. That's why you have KI here in the denominator. So always the permutation of NK will be, the number of ways here will be more than NCK. Okay, the number of combinations using the same total number of objects and the same number to be chosen. Okay, example, if there are 20 players and we want to select 2 co-captains, okay, anyone who will be chosen as co-captain, he will be co-captain. It doesn't matter which one comes first. So how many ways we can choose them? In this problem, the order doesn't matter, as there is no difference between who will be selected first as co-captain position, because he will be co-captain. So it is a combination problem. So here we write it in our way. It will combination, so it will not be in PR. It will be in C R or NCK. It depends on the notation which you are using. Okay, so it will be written as NCK. Okay, great. So how to write this one? The same way I wrote the permutation, n factorial, this minus this, n minus k factorial. Don't forget this factorial. Then because it is combination, we have to repeat the k only again, k factorial. Okay. So it will be, this is the formula. It will be 20, the total number 20. I need to choose only 2, so the k equals 2. Okay, and equals 20, and the k equals 2. This is 2, the number of selected or chosen positions. Okay, so 20 here, 20 also, minus 2, and then times 2 factorial also here. So 18 factorial times 2. I cannot say that 18 factorial times 2 factorial equivalent to 20 factorial. No, I have to expand 20 factorial until I reach the biggest figure here, the biggest factorial here, so I can cancel it with it. So 20 factorials will be expanded as 20 times 19 times 18 factorial. Then here, from here, I reach 18 factorial. I can cancel this 18 with this 18. So I end up with 20 times 19 divided 2 factorial. 2 factorial can be expanded 2 times 1. Doesn't matter the 1. I can cancel it. So here I can cancel 2 with 20 equals 10. So 100 and the answer will be 190. Okay, I hope this is clear and very simple example, because we already got in touch with it in the previous slide. Okay. Okay. Coming here to another example, example number 2 on the combination as well. And here, just I highlighted the formula for us to remember it. NCK equal NI, N minus K. Okay. KI factorial. So n factorial, n minus k factorial, k factorial. So the way I'm repeating it, just to remind to remember it, and just to keep it in mind, because it's good that if you find a way to memorize the things. Example, a board has 10 women. So look carefully at this example because it is not a traditional one. A board has 10 women and 7 men. Okay. So this example is very, very complex and a challenging example. If you fully digest it, I think you'll be able to answer all the combination problem, and you'll be able to digest any formula or any way of explanation of the combination, because some of the universities are using complex way to explain, or some complex slide to explain this combination. So here, concentrate with me, and by the end of this example, if you digest it, I think that you'll be in a very good position to fully understand the combination. So here, I have 10 women and 7 men. So I cannot say that I have 17 people as n equals 17. It could be in some cases n equals 17 if I'm talking about the people, regardless of the gender of the people, I can say 17. But if I'm talking about the women, I have to consider n equals 10. If I'm talking about the people, the men, I have to consider n equals 7. If I'm talking about all the people, I can consider n equals 17. So it is not given that n equals 17. It depends on the question. If he's asking you about the woman, so this is the total number of the women, 10. You cannot choose 11 because you have only 10 women. You cannot choose 8 or 9 men because you have only 7. Okay? But you can choose 12 people out of the total of men and women. So I have to concentrate what is your n in your question. So the n in this case, because in this case you don't have a straightforward n. Usually the trick will be in the k, whether we have k or r equals the 2 or 3 or 5 people, or 2 digits, or 2 alphabetical, some of them is identical or repeated or duplicated or no. But this trick in this example will be in the n itself. So n here is 10 plus 7. I can consider 17 in some cases. If I'm talking about the total number of the population, total number of the people, I can use it as 7 if I'm talking about the men. I can use n also as a 10 if I'm talking about the woman. How many ways to form a committee containing 4 members? So if I'm talking about members, so n is 17. But here, in this problem, he will specify who are the members. So the total number of the members will be 4. 4 is our k. So k equals 4. But n equals, this is the thing which I have to identify. It is not clear to me which n. I could be 17, it could be 10, it could be 7. It depends. Total number of members, or men or women. Okay? But my k, the number of committee members which will be selected, are 4 members. So I have k in this example, but there's this problem, but I don't have n. Okay. So he said here he will choose chairman and the vice chairman and secretary. No. He said that someone will take advantage of the other one. No. Anyone will take benefit or will have anything more than others. No. So in this case, or some one of them will be the parent and the kids, for example, in a movie. No. So in this case, the order doesn't matter. So it is a combination problem. The order doesn't matter, so it is a combination problem, because he need any 4 members. Any 4 members. This 4 member, if we're talking about normal people, could be men, could be women, could be anything, because he's a member. Any one of the 17 people is a member. So any one of them is a member. He can be any of these 4 people. Doesn't matter. If he's talking about the men, in this case, we have to choose from the men. If he's talking about the woman, we have to choose from the woman. So, okay, so let us see the problem. So this is the first question which we have here. The order doesn't matter. So he says such that. So he said, how many ways to form a committee containing 4 members such that what? All the 4 members are men. So here this is the problem. All the 4 members are men. So at the end of the day, the four members are K. Okay, so I have K 4. So what is my N? He wants my N to be the men, the total number, the population which I have. What is the population of the men? The maximum number I have of the men. In this case, N will be equals the men number 7. Okay, so N equals 7 and the K equals 4. So my problem will be its combination. So it will be total number 7. I have to choose 4 out of them. Okay, the answer will be 7 factorial, 7 minus 4 factorial, then 4 factorial. So 7, and I'll choose the biggest one and expand this until I reach this one. So 7 times 6 times 5 times 4 factorial, 4 will be cancelled by 4. So I'll end up 7 times 6 times 5, and the denominator 3 times 2 times 1, 3 times 2 equals 6, will cancel with this one. So 7 times 5 equals 35. So I have 35 ways to form a committee of 4 members, and all of them are men. 35 ways. Okay? Okay, great. So here, he said that the 4 members such that, read it again, 4 members such that 2 are men and 2 are women. Okay, so now he changed my K. My K was 4. I have to choose here 4 members. Here I have to choose 2 only of the men. So my K changed and my N now is limited to the men. I have also here 2, my K is 2, and the N is 10, the woman. So I have N1, the men, which is 7, and the K1 is 2. And also I have the woman, N2 is 10, and the K is 2. So this would be mine. So in this case, I have how many number of ways? The number of ways to select 2 men, and times the number of ways to select 2 women. Okay? Okay. So it will be 7, which is same as this one, which is the formula which we have here. Okay? This one, so it will be 7 number of people, the men, and you select 2 out of them. Okay, times I have 10 number of women and I select 2 of them, and this times this combination times this combination. So let us write the first combination, 7C2. It will be 7 factorial, 7 minus 2 factorial, 2 factorial times the second one, 10 factorial divided 10 minus 2 factorial, 2 factorial. So I'll expand this one until reach 5, expand it and then cancel. Okay, times here expand until reach 8, I'll cancel. So this will be the answer, it will be 945. You can imagine, because I choose 2 men and 2 women, and the total number remained the same. The committee is 4. Here it was 4 members, and here also 4 members, 2 plus 2. But here all are men, so I have 35. If I choose 2 men and 2 women, I have 945. Okay? Okay. This so far it's great, and I think it is not so difficult. The next one will be the most complex one, and I think we have to concentrate on it a little bit. Okay? He wants here at least 1 woman. The number of way of choosing at least 1 woman, the number of ways of choosing any 4 people from the overall, because I need overall 4 people, but I want at least 1 of them will be woman. So what can I do here? I can get the number of ways to select any 4 people, any 4 men or women, any 4 out of the members, for any 4 members out of the total population. Total population is 17. Total population is 17. I need to select or to choose any 4 of them. So this will be the total number of the total number of ways to select 4 members. Then I minus from them the number of ways that this will not have a woman. Will not have a woman. Okay? What does it mean? Will not have a woman? That means that the number of way to select a man, okay? So if I select when will not have any woman if all of them are men, right? If all the people selected are men, in this case only will not have any woman. But if we selected two men, we'll have two women. If we have selected three men, we'll have one woman. If we have selected zero men, we'll have four women. But if we selected all the members men, we'll not have any woman. So I said, okay, I say, for example, I have number of ways to select the four member is 100, for example, and the number of ways that the people will be all men is 35, for example. So it'll be 100 minus 35 equals 65. This is the number of ways that I have at least one woman. At least could be one, could be two, could be three, could be four of them are women. Okay, I hope this is clear. So here at least one woman. The number of ways of it choosing at least one woman means the number of ways of it choosing any four members or any four people from the overall number, okay, minus, because this is the maximum number. I can choose anyone from any group, which is a huge number in thousands, okay, minus the number of ways that all of them will be men, choosing four men out of the seven men, no woman, okay. So like the normal property problems, when we say that at least means one minus the property of the opposite and minus one. For example, if at least two, one, at least one, minus three, make it two. So and so on. So here, what we are saying here, at least one means that in all the cases I will have woman except if it is zero. If zero woman means I don't have at least one. So at least one condition, it happens always except if at any point of time it is zero. When it will be zero, I don't have any woman if I have all of them are men. So I get the number of ways that all of them will be men, and I will deduct this number, which we have already got here. All the members are men. I have to deduct this 35 ways from the total number of having any four members. Okay, I hope it's clear. So N1 in this case, the total number of people, of members from any arrangement, N equals 17, and I need to choose four of them, any four from the 17, any four from the 17. And then minus, so it will be 17 C4. I want to pick four people, any four members out of the 17, the 17 men and women. Minus, this is minus the choosing four people out of the seven men. The four people will be seven. Sorry, the four people will be men. Okay, so I have to subtract the number of ways that the four people will be men from the total number of ways, which will be 17. Okay, 17 minus 4 divided 4 factorial also. Here also 7 factorial divided 7 minus 4 factorial divided times 4 factorial. Okay, so I can simplify this until I reach 13 times. I can simplify this until I reach 4, and then the answer would be 2345. Here you can see the number increasing drastically. Okay, I hope this is clear and this covers, I think, all the points which we have studied so far.